Hello, welcome back, my dear students, my lovely students. Welcome back to your channel of learning mathematics. Today, we are going to learn a new chapter from class 10. Class 10th mathematics. We are going to be learning a new chapter, that is chapter 6. That would be triangles. So it's not going to be the same chapter of class 9, but yes, a continuation of chapter 9. Okay, so yeah, let's get to it. So like previously in up to class 9, we have learned actually like a lot of triangles, starting from congruency. What are congruent triangles? Up to class 9, we have already learned so much about triangles, different types of triangles, acute triangles, obtuse triangles, right angle triangles, what is a triangle, all that we have learned. And actually I have done that again in a video for class 9, so I'll provide you the link below. You can check in the description box below, and if you wish, you can revise that, some more properties about triangles from that particular video. Now let's do a quick recap of what we have learned up to class 9. So I'll not go in detail. We will just see what we have learned in class 9. So in class 9, of course, for the first thing that we have learned is about congruent triangles. But I'll get back to this congruent triangles in a little bit later part, okay, after some time. All right, before that, let's just try to revise some of the properties, or yeah, something like some of the properties that we have learned so far in triangles up to class 9. One of the property that we have learned is like angles. In short only, in brief only I'm writing, okay. Angles opposite to equal sides are equal. Number 2, similarly sides opposite to equal angles are equal. So the first one simply means like if you have a triangle, and then like let's say you have 3 angles, then of course, so A, B, C. So here what we have learned is angles opposite to equal sides. So if here AB is equal to AC, so in that case angle B is equal to angle C. And this one, sides opposite to equal angles are also equal. So similarly, in the same triangle, in let's say another triangle PQR, if the angles are equal, if angle Q equal to angle R, that is angle Q equal to angle R, then their sides opposite to the angles, that is PR, is also equal. So opposite to this angle, it is this side PQ. So that's what it meant. This is just a quick recap. Then we have learned about inequalities, EQUALITIES, inequalities in a triangle, that which says in brief only, okay, sum of any 2 sides in a triangle is always longer or bigger than the third side, is always longer or bigger than the third side. That means like maybe we have a triangle like this, again say A, B, C. What it states is that if you take the sum of any two sides, AB plus BC, let's say, is always going to be greater than the third side, and with the other sides also. Another property that we have learned is also, again, that is side opposite to the larger angle is the LONGER, longer side. That is, a side opposite to the larger angle is the longer side. So it's something like, maybe we have a triangle like this, and let's say if this is the, of course it somehow looks like that, if this is the biggest angle, then the opposite side to the biggest angle AC is the longest side. So that's why in a right angle triangle also we can automatically see that the right angle is the biggest angle, because it is 90 degree. The other 2 angles will be complementary, so automatically the opposite side becomes the biggest side, or the longest side AC, which is known as the hypotenuse also. Okay, so these were some of the concepts that we had already learned in our previous class 9. Then of course, yes, we do study about more in detail about congruency. But before we really go to congruency, anyway, let's okay, so before we really go to congruency, let us see what we are going to be studying about here in class 10, triangles. Here what we are going to be studying is about similarity. So in class 9 we studied about congruency. In 10 we are going to be studying about similarity. Of course all these properties will remain intact. Okay, it's not meant to change. But yes, we will be learning a new term that is called similarity, similar triangles. In class 9 we have learned about congruency, congruent triangles. But before we go deeper into congruency and similarity, let's clear the concept of what do we mean by congruent and what do we mean by similarity. So let's say GRUEN. Let's talk of congruent figures, FIGURES, figures. Okay, just in general, it can be squares. In general, polygons. What is a polygon? Any side which is having more than two sides. Any figure, any figure which is having more than two sides is called a polygon. So we have so many polygons, isn't it? Like triangles, pentagons, hexagons, octagons, decagons. We have so many polygons. Triangle is the smallest polygon, let's say, the polygon with the least side because it has three sides. Then similar figures. So I'll just give you in brief, that is congruent figures. The condition is like, if you remember, it should be of the same size and it should be of same shape. So if you remember, it has to be like exactly the same. Nothing should be different. It should be just a Xerox copy, the copy. Whereas similar figures, what we will be learning is it should be of course of the same size, but not necessarily, same shape. Okay, it should be of the same shape but not necessarily same size. All right, confused? Definitely, but don't worry, I will clear that confusion for you. Let's write it down once again. Congruent figure. It's always good to know the concepts before you really do a chapter. Okay, so many students struggle with geometry because the concept is not clear, but geometry, it's a very unique topic. If you are clear with the concept, for example, when we are talking of triangles, like what is a triangle, what are the properties of a triangle, if you know all this, then definitely every problem would seem to be very easy for you. But don't worry, I'm here to make it easier. Congruent figures and similar figures. What did I say? It should be of same shape. So similar figures also same shape, but here it should be of the same size. Here, but not necessarily of the same size. Now let me clarify that concept for you. Okay. All right, look here. See, I've prepared two figures for you. This is something like a rectangle, isn't it? So you can see that they are exactly the same. No? They can be overlapped with each other also. No extra size, no extra portion will be left. Perfectly same. So these figures are called, what do we call them? Congruent. What do we call them? Congruent. So because they are of the same shape and same size also, isn't it? Chalo. Now I'll give you another figure. I'm going to give you another figure again. This one. We have two circles again. So this also same shape, same size. So this also will be congruent. All right. Fine. So I hope the concept of congruency is clear, isn't it? Just a revision only. So you can see it's perfectly overlapping. Now what I'll do is, now you tell me, see, another circle, right? Another circle. Now you see. They are of the same shape, of course, no doubt about that. Circle, same shape. I did that cutting for you, right? So They're of the same shape, but are they of the same size? No, they are not of the same size. But yes, we can call them similar. Alright, so that's the meaning of similar figures. Alright, but now if I remove this and bring in this this one, let's say this. Now what do I call them? I would call them nothing. Okay, because they are completely, see, the condition is they definitely have to be of the same shape. Okay, so if they are of different shapes, then they are not congruent as well as they are not similar at all. Alright, okay, is that clear? Fine then. Now what about this? Now since we'll be talking about triangles, you can see that these two triangles are almost, of course, same shape, right? And but not of the same size. So what do we call them? We will call them similar. So the first exercise is basically about this concept only. So I hope you can do that first exercise. I'm not going to do that for you. You can give it a try. If you have problems, you let me know. All right. So I hope now the concept of similarity is clear. Similar and congruency. All right. So similar figures means same shape but not necessarily of the same size. So but another thing that we should understand is, see, if we talk of the two circles, definitely they are congruent, isn't it? Same circles. And will they be similar? Of course, they will be congruent as well as similar. They will be congruent as well as similar. So from here we understand one thing, that their congruent figures definitely are similar figures also. But similar figures need not be congruent. All right. Okay. So let's see some general rules for similar figures. Some general rules for similar figures. Now we're talking in general only. Figures. Okay. So two polygons. Remember, triangle is also a polygon. Okay. So two polygons with same number of sides. So remember, we can compare only a triangle with a triangle, square with a square. We cannot compare two different shapes. Okay, are said to be similar when the condition is this: corresponding angles are equal. See, just by observing, actually we cannot say that whether they are similar or not. Of course, here we could easily say that they are similar because it is tailor-made, perfectly cut, but just by observing we cannot say that they are similar, because there are some rules also again which we have to follow mathematically. Okay, so what are those rules? I'm giving it to you now. Their corresponding angles are supposed to be equal and their corresponding sides are in the same ratio. Let me go back to congruency. Congruency, if we had two triangles, let's say two triangles A, B, C, P, Q, R. So if they were congruent, then the condition was they can be congruent only when the corresponding side, this side and this side, corresponding sides. That means if you rotate the triangle, both the triangles anti-clockwise, their sides will remain the same. Okay, positions will remain the same. Angle C equal to angle R, and also their corresponding sides AB is equal to PQ, AA, PQ. Now you can see AB, PQ, PQ. So that direction also has to be maintained. AC is equal to PR, BC equal to QR. Okay, now for similarity, what they mean is, if you take two triangles again, if you take two triangles, let's say A, B, C, again I'll take P, Q, R. Now similarity, how do we denote? We will denote by just this side. See, it's very clear. Congruency means everything exactly the Xerox copy, everything just the exact copy of itself. That's why this equal to sign is also there. But in similarity, it need not be equal because it can be of different size, not necessarily same size. Alright, so that's why we just use this notation only. Here also the first condition is, as I said, corresponding angles are equal. So angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R. But the corresponding sides not equal, but they should be in the same ratio, that is AB corresponding sides, so AB PQ, which should be equal to their ratios, no? Proportional. AC by PR should be equal to BC by QR. So for similarity, this is the condition, and in class 10 we are going to be dealing with this condition only. Okay, all right. Now let me give you one example. Okay, let me give you one example. Let's say that two triangles. Let me just say the two triangles like this. So let's say this is A, B, C, and the bigger one, let's say it's P, Q, R. So 50 degree, let's say 70 degree, 60, 120, 120, 80, yeah. 50, 70 degree, 60 degree. Let's say this side is 5, this side it's 15, this side is 6, this side is 18, this side is 10, let's say this side is 30. So if you consider these two triangles, are they similar? Now, see, I've written down the sides also for you, no? ABC, 50, 70, 60, 5, 6, and 10. And this triangle PQR, right? 70, 50, 60, 15, 18, 30. Now let us just assume that maybe our triangle was like this, and then we were told to like check whether it was congruent or not in this form like this. So we also have to know how to rotate that triangle, and always do remember, of course it's up to you, clockwise or anti-clockwise really doesn't matter, but we will just keep it in one direction. So we'll try to rotate the triangle in anti-clockwise generally, because angles we measure in anti-clockwise. So I'll try to rotate the triangle anti-clockwise till I get the proper alignment, no? 50 50, 70 70, 60 60, then we'll have the corresponding sides. All right, so sometimes what happens is it might be given to you like this also. So at first look we might say that no, they are not similar because upside down. But no, hold on, wait, look at it carefully, because you can see some similar angles, same angles. So what do? We try to rotate the triangle anti-clockwise. Okay, mentally, of course, we will not be cutting down the paper and then doing that. So if you just try to rotate, and you can see, yeah, got it, no? So now you see that angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. And if you go for the ratios, that is AB by PQ, AC by PR, and BC by QR, so that would be 5 by 15, 6 by 18, 10 by 30. So what are the ratios? 1 by 3, 1 by 3, 1 by 3. So therefore AB by PQ is equal to AC by PR is equal to BC by QR. So we can see that the sides are in the same ratio, the corresponding angles are also equal, and the corresponding sides are also in the same ratio. So in that case we can go on and say that triangle ABC is similar to triangle PQR. So that is what we are going to be doing here in class 10, my dear children, about similarity. All right, but yes, every time we go for proving that the two triangles are similar, it doesn't mean that we will have to prove both of this. No, just like congruency, we will also be having some criteria. Remember, in congruency we had angle criteria, side criteria. That means if you can just prove that three sides are same, ho gaya, they are congruent. Three angles are equal, ho gaya, congruent. Or angle side angle, no, not this one, sorry, not angle sorry, not angle for congruency. Angle side angle side are right hypotenuse side. Right, so these were some of the criterias in general, which we use for congruency, to prove congruency. We will have the same here for similarity also. We will have the same here for similarity also. Okay, so it's not that you will have to prove all the three sides and the three sides and the three angles. No, you'll have some criteria. With the help of those criteria, we will prove that the two triangles are similar. We will check whether the two triangles are similar or not. All right, so it's not a very difficult chapter. It's a very small topic, simple topic about similarity only. All right, then plus we'll have the Pythagoras and the converse of Pythagoras theorem, basic proportionality theorem, all based on similar figures. Okay, so that is what you will be having here in class 10. So I hope that you've got some slight concept about similarity and similar triangles. So thank you for watching. Next up, in the next video, I will be doing the basic proportionality theorem. So if you anticipate and if you have liked the video, please do let me know. I will be eagerly waiting. Okay, so see you in the next video. Bye bye.